Hi everyone, this is Dr. Schnars, Director of the Regional Science Consortium, and today what we're going to talk about is a program we developed for our NOAA Be Wet series, and it is talking about shipbuilding and then being able to test those ships that you guys build in a wave tank. So when we look at how ships are built, we see that there are just a couple basic structures that are really used on most ships that we see sailing on the lakes or the oceans. And so when we review these different types of ships, we're often looking at the hull or the bottom of the boat. And so the first one is a flat bottom hull. And these are boats that are very stable. They're great for fishing and use on calm weather, in small bodies of water. You can see a diagram there. It has a very square bottom to it, which allows for a lot of that stability. So you're able to move around on the boat without it tipping too much. So when we look at round bottom hulls, these are displacement hulls. So they're designed to move smoothly through the water and kind of push the water or displace the water out of its way. And a really common example of this would be a canoe. So you can imagine being in a canoe. It moves with, very little effort and kind of glides through the water very quietly. Drawback with a canoe, as you might imagine, is it's less stable. So as you're getting in and out of the boat, it can tip or capsize more easily. The third one that we're going to discuss is a V-shaped hull. And V-shaped hulls are planing hulls. So these boats are nice where instead of displacing the water, once you get it up to a pretty fast speed, you're actually planing on top of the water. So you don't have that resistance of the water being where you have to push that water out of the way. And these boats are usually equipped with a larger engine than a flat bottom or a round bottom boat, which allows it to get up to speed much quicker, so you can go ahead and plane on top of the water. Now, interestingly, there is also another boat called a multi-hulled boat, and the one here is showing 2 hulls in the water, but it can even be 3 hulls, and these boats are typically catamarans. They can either be planing or displacement hulls, and it depends on the shape of the hull and the type of engine that it's outfitted with. And multi-hulled boats are some of the most stable on the water. So as you can imagine, when you're moving from one side of the boat to the other, you're not going to tip very much at all. They also require more room to steer and turn the boat. So as you're turning the boat, say to the right, you're going to have a big sweeping turn as opposed to a sharp turn like you might see on a faster boat. And examples of these are catamarans. So the one pictured here is a catamaran, or even a pontoon boat that a lot of times you'll see on calm bodies of water like small lakes or even the lagoons out here at Presque Isle State Park. Now, when we think about boat building, there are several materials that are typically used. We have wood, aluminum, fiberglass, and steel. And wooden boats have some advantages. Some of the first boats ever built were out of wood, and that's because if you put a large log in the water, it just naturally floats, so it's naturally buoyant. And it does not require extra buoyancy to be added to the boat to make sure it would float. It's strong, so wood is actually stronger than steel when you compare it, like the strength of the material to its weight. So it's incredibly strong. And it's very pliable, so you can see how the curve of the boat there, they were able to kind of bend those planks of wood to make that shape. So it has a lot of flexibility. It also absorbs the shock and vibration of the water. So as you're going across the water, sometimes when it's really wavy, you'll notice that the boat will kind of bounce on the water, and that makes for a rough ride. But wooden boats like this one will actually absorb a lot of that shock. And then it's rigid enough to support decks and masts. And if you remember, some of you came out to visit us at the Maritime Museum and visit the flagship Niagara, and you can see how big those masts were on that boat. Now, some of the disadvantages of a wooden boat is that it can degrade in water. It is an organic material, so it is prone to rot after long periods of time. But the solution to that is annual maintenance, sometimes with a fiberglass resin to help seal that off, or even replacing some of those pieces of wood that do become rotted. And so they are high maintenance. So a lot of wooden boats that you see today, you'll notice that those owners do put a lot of maintenance and care into those boats every year. And so that is one drawback.
Alright guys, so we're talking about the different materials that boats are made out of. And another material that we're talking about is wood. So you guys probably remember from the beginning of the year, way back in September, when you came out to visit the Maritime Museum, you were able to go on the flagship Niagara, a wooden boat, very large. It's a replica of the one that used to be here. And you can also see the Letty, and that was the one that you guys got to go for a sail on out on Presque Isle Bay. And so both of these boats are made of wood, and if we look back at the boats that were used on Lake Erie 100, 200 years ago, wood was one of the first, most affordable types of materials in order to build these boats. It was also something that floated naturally, and we really got to see all of the different pieces and parts of these boats and how it worked together. You can see behind me now, though, that both boats were put to bed back in the fall to make it through the winter, but they should be uncovered pretty soon here as we get closer into the spring and closer into summer.
Now, another type of material would be aluminum, and aluminum is lightweight and resistant. It is a very strong material. It can handle impact with other objects, meaning that if you were coming up to a dock and accidentally, maybe your driving skills weren't perfect, accidentally bumped into that dock, the boat would really probably not see much damage from that, as opposed to looking at other materials boats are made out of. It's very durable and it does not deteriorate over time, and it really resists corrosion. So it's a good long-term material to use for a boat. You can also make very easy repairs to it, lower maintenance. And the kind of a drawback is that it can be noisy and uncomfortable. So when you're out on the water, sometimes it has that echoing effect, almost like being in a tin can. So it's not really a comfort boat, but more of a work boat. The other thing is that it's lightweight, so it can be moved around easily by the waves. So it can kind of get pushed around maybe in high seas or high waves. Our next material is fiberglass, and the advantages here are that it's very easy to maintain, less repairs and leaks compared to other materials like wood. It's also easy to clean. It's lighter weight than a wooden boat and lighter to push through the water, so it makes it a little bit easier to go fast. And it sits high in the water because it actually has a foam core. So this has an added material of foam to increase its buoyancy or allow it to float better. It also provides a quieter ride. So most boats that you see maybe out on Lake Erie or smaller lakes near you are probably made out of fiberglass. And so it is more of kind of a relaxing luxury boat, meaning that you can go out and just have fun, whether it's going for a boat ride or water skiing, things like that. A lot of times they do have cabins as well, and they're very easy to repair. Some of the disadvantages is that there are timbers or pieces of wood that are inside the fiberglass and foam that help hold its structure. And so when those become damaged or begin to rot, they can be a little more difficult to get to and also to repair or replace. And damaged areas can result in fiberglass absorbing water and rotting. So that just means that as different damage happens to it, you just have to maintain it and take care of it quickly and not let those things go.
So another material that we talked about to build ships out of or boats is fiberglass. and you can see the talk of the town behind me. It has its sails down right now, but this boat is made out of fiberglass, which is kind of like a plastic resiny material, and it's very durable. It's great for boats that go at high speeds. It's very lightweight. It's also easy to patch. So all of these different types of materials we can build boats out of all have advantages. And remember, it really depends on the function of what the boat is going to be used for. So this one right here, you can see it is also a different hull shape. So the hulls that we were looking at with steel boats and wooden boats are more of that V or that curved shape, or they can even be a more square or boxy shape. This one here is a double hull, so you can see it has two hulls to it that is connected by a piece in the middle. And those two hulls allow it to go much faster. So it has only those two hulls that are touching the water, and it's not going down into the water. It doesn't have to displace a lot of that water in order to move forward. So that allows it to go much faster. So it's just another hull type as well as another material. And these boats are used for recreational purposes, for fun, and it can often get places much faster than some other boats we might see.
So one of the, I think, most interesting boats that are made out of fiberglass, it's a type of boat called a Boston whaler. And when these were developed many years ago, they were termed an unsinkable boat. And that was because it had this foam core construction. So even if you were to saw this boat in half, right where that steering column is, right where the people are standing, if you were to saw it in half, the boat would still stay afloat. If you were to fill the boat with water, it would still stay afloat. So that's pretty impressive. And now today, all motorboats that are under 20 feet are required to have positive flotation, so that if they are completely swamped or filled with water, they'll still float. And that was modeled after these Boston whalers that were developed. So this foam is a closed cell foam, and it has other non-permeable material or material that won't soak up water and weigh it down. Finally, the last material we want to discuss is steel. Some of the advantages are that they are most rugged against abrasion. So if it were to collide with anything, most likely there would be little or no damage. They're easily constructed. There is a comfort level, so as you are on these boats, the ride is very smooth. They can survive extreme conditions. So if you look at some of the steel boats from our military, a lot of them are still around. And even though they might not be used anymore, they might be part of museums or things like that now where you can go and tour them. So they have this longevity or kind of long lifespan to them. And they also have low maintenance. Now, some of the disadvantages are they do corrode because of the material. They are very heavy, so that means they displace more water, so they kind of move more water out of the way. And it requires a larger engine and uses a lot of fuel because of that. So these boats need to be at least 100 feet long in order for them to be worthwhile for the cost of the engine and the cost of the fuel to move them around.
All right, so we've been talking a lot about shipbuilding and how these different boats and ships really formed Erie, Port Erie, so Erie, Pennsylvania. We had shipbuilding here, we had commercial fisheries here, we had dredging of sand, we had all kinds of things going on, all kinds of businesses really related to the lake. So the ships and boat building was another industry that was important to support all of these other businesses. So the ship behind me that you see is still ones that we see on Lake Erie today. This is one here at the Don John, which is a shipbuilding yard, but also does a lot of repairs, especially during the off season. And these are big freighters that'll go throughout all of the Great Lakes, and they can even be transatlantic. So it can even go from here over to Europe across the Atlantic Ocean. These boats here we're talking about what boats are made out of. So this is made out of steel, and you can see that this boat is very long, a couple 100 feet long, and the different types of material that were used on these boats, as we were mentioning, has a lot to do with the function of the boat or what it's doing and what job it has to perform.
So when we design boats, those are the basic structures, and those are some of the materials that we use, that we see used in boat building. But we also have to think about the form and the function of the boat. So what is the purpose of our boat? So today, what I'm going to ask you guys to do is build your own boat. And as you're building that boat, think about what are you going to use that boat for? Is it going to be fishing or just cruising around? Is it going to be racing? Do you want to get from one place to another very quickly? Or do you want it to be slow and relaxing? Is it going to be used for maybe transportation? Maybe it's a boat for a business that is moving people around like a ferry, or moving different products or goods around to different warehouses. Or is it a military boat? I mean, the function of the boat really dictates the form or what kind of shape, and also that plays into what kind of materials are used. And the other thing is location. Where are you going to use this boat? Is it going to be out in the ocean? And then you have to think about a lot of the weather that comes with that and waves. Is it going to be on a lake? Is it going to be on a Great Lake, like Lake Erie, or a smaller lake? Or is it going to be on a large river? So that is also going to dictate which boats would work best in those different locations or scenarios. And then keep thinking about weather. So all those different locations, you have to think about what types of waves, but also winds, water currents. This picture right here is showing a couple water spouts. We do get water spouts on Lake Erie, so that is another weather event that you would want to think about, and also lightning. So how is your boat going to fare in any of those stations? So when you design your boat, again, think form versus function. What's it going to be used for and where it's going to be used for? And then start, with just a piece of paper and sketching out what the boat will look like. And then what I want you to do is go ahead and build a boat. And if you were in our labs, we would have materials similar to the materials you could find in your house. So, things like maybe aluminum foil, maybe some paper or plastic or styrofoam plates or cups, some wooden craft sticks like popsicle sticks, tape, string, pipe cleaners, any types of arts and crafts material that you might be able to use to assemble this boat. And then if you get a chance, try the wave tank test. So even though we can't see you in our labs and use our wave tank, there's no reason why you can't use a wave tank like a glass mixing bowl or a casserole dish, or fill up the bathtub and stick your boat in there and just kind of from one end of the bathtub or your wave tank, go ahead and make some first of all, don't make any waves at all. Just put your boat in there and see if it floats, and see how it floats. Is it very tippy? Is it very stable? And then on one end of the wave tank, go ahead and just initiate some low waves. So just use your hand and paddle it back and forth very slowly, and see how your boat kind of fares those waves. Does it seem to be like it's going to capsize, or does it capsize? Does it just tip over on its side? And realize that some sailboats out there actually go pretty far on their side. So does it still stay afloat? Does it take on water? And then go for the high waves. So without making a mess, go ahead and put some high waves on that boat and see how it withstands. See if it capsizes, or see if it, fares those waves. And then if you want to get a little more creative and really put your boat to the test, go ahead and add some ballast weight. And this just can be some coins that you have, maybe some pennies or nickels. Just go ahead and start putting those on the boat and see how much weight it can handle, and then test it against those waves and see what that boat is capable of. The other thing I want you to try to do is build a boat that is completely, just completely different. Maybe that doesn't use any of those hull types that we discussed, and see why boats aren't built like that. So see why the boat capsizes or sinks. Is it too tall, or is it too top heavy, or does it not have a wide enough base to it? So test things that you think won't work and understand why they're not working. Now let's check out some of the boats built by our friends at Penn State University, the Society of Women Engineers. Now that we gave you some ideas, now you go ahead and try it. Use materials you can find around your house, any types of arts and crafts types materials, and go ahead and try to build something. Test it out in your own wave tank, and then share your boat results as well as maybe a photo of your boat with your teacher. We were excited to work with you. Thank you again for participating in this. And again, this was a project funded by the NOAA Be Wet program and brought to you by the Regional Science Consortium.